Alright, so now it is time to learn how to solve non-homogeneous systems. But let's we first go back to chapter 4. So here we have a homogeneous differential equation. Now to solve this, what do? We write the auxiliary equation and we find the roots, right? So let's say we have a homogeneous system, x prime is equal to ax. What do we do first? We first find the eigenvalues. So eigenvalues and the roots of the auxiliary equation, they have the same idea, right? So you can see an analog. All right. Now, if you can remember, so when we find the roots, we can clearly write down the general solution for the homogeneous system when you have a differential equation. And in chapter 4, we gave a special name for that. What was that special name? Complementary solution, y sub c, right? Complementary function. So the general solutions that we found in by solving x prime is equal to ax, since this is a homogeneous system, what we found is actually a complementary function, x sub c. Okay, so we use the same name in systems. Okay, all right. So now let's say we have a non-homogeneous equation. Now, when you want to solve this non-homogeneous equation, what is the approach you take? No matter what method you use, first you have to solve the homogeneous version of this differential equation, right? First you have to find the y sub c. For example, in method of undetermined coefficients, you find the complementary function, then you guess the particular solution and you check for overlap, right? Then you come up with a good guess or a trial form for the particular solution, and then you use the rest of the method, right? So it is same in the systems. Okay, so you first have to find, so let's say you have a non-homogeneous system, x prime is equal to x plus f. So first you have to find the complementary solution, or that means solve x prime is equal to ax. Okay, the homogeneous version of the system. Okay, that means find eigenvalues, find eigenvectors, write the general solution. Now, how can we find the particular solution when you have a system? Well, you already see there are plenty of analogs with chapter 4. So guess what is the method we are using? Your favorite method of undetermined coefficients, or we can use variation of parameters. So we are going to learn both of them again for systems. Okay, all right, so let's start with method of undetermined coefficients. Now it is the same procedure with section 4.4. okay, but there are a couple of slightly different things, two different things. When we have systems, okay, well, you have to find x sub c, the complementary solution. That's same, okay, eigenvalues and eigenvector story. But when you want to guess the particular solution in a system, your part that accounts for non-homogeneity is actually a vector. So see here, so this is an example. So if we write this as x prime is equal to ax, a is 2 1 1 2 times x plus f. The part that accounts for non-homogeneity in the first equation is t, right? So it's t here. In the second row, it's 1 plus e to the negative t. So see, now this is the non-homogeneous part, capital F. Now that is a vector. But in section 4, the chapter 4, we got functions, right? So that's a major difference, okay? And in chapter 4, we had the non-homogeneous part actually on the right hand side of the equation, right? Just like here, right? 2x plus 1. But here it's a little bit different the way we write, right? Okay, so you have to identify this capital F clearly. Now then the other difference is coming from when we are dealing with overlaps. So that is a story for next video. Okay, so here let's learn how to write the correct trial form, or how to come up with the correct guess when you have a vector as your non-homogeneous part. Okay, all right. Now what you do is, really, when you look at this non-homogeneous part f, okay, and then keep it aside, take the homogeneous version of the system 2 1 1 2 and solve it. How do you solve it? Well, now you know how to solve it. Okay, find eigenvalues, find eigenvectors, and write the general solution. So here I'm not going to spend time on doing that. You already know. So try to pause it and do it. Okay. So eigenvalues are 1 and 3. So I will give you that. The corresponding eigenvectors are negative 1, 1, 1, 1. So the complementary function now is capital X sub c is c1 negative 1, 1 e to the t plus c2 1, 1 e to the 3t. So this is the complementary solution. Now keep it aside. Save it. Okay. So you can see it's the same analog as chapter 4. Now you look at the non-homogeneous part F. Okay. So what you have to do is you have to identify what type of functions you have in that non-homogeneous vector part, because this is a vector. What type of different functions you have? You have 3 types of functions. Carefully look. T, e to the negative t, constant. Okay. Now look at here. T and constant, they have a connection because t is a linear term, right? So it's like x. So it's like ax plus b. Okay. So you have a t term. Okay. And you have a constant term. Okay. And you have an exponential term. So you have to write a vector accounting for each of these parts. For t, you can write your trial form as, okay, for the part for t, as t, it's a vector, okay, with 2 rows, a and b. A and b are the constant that is to be determined. Plus now for the constant part, constant vector is just cd, okay, plus exponential part e to the negative t, ef. Okay, so now this is the guess for the particular solution. Okay, the initial guess. All right, so see how I did it. Okay, so it's a vector. So identify the different parts of the function and write a vector for each type of function. Now you can see this as a linear function. Okay, but I still separated t and constant so that I can account for each parts. Okay, all right. So this is the guess for the particular solution. Now you want to check for overlaps. Now do we have an overlap? Now if you look at your complementary solution, any overlap should come from these exponential parts, right? Here e to the t, here e to the 3t. So does e to the t times negative 1, 1 have a connection with these 2 parts? No, right? They do not have an overlap because this vector is multiplied by this exponential function e to the t. So the only exponential part we have in this our guess is e to the negative t part, but that is different from what we have here. So there's no overlap at all here. Okay, so that is how we decide the overlap. All right, so let's look at another example. So this is final. So this is our guess for the particular, correct guess for the particular solution. All right, so in this video we're just learning how to guess. Okay, so let me show you another example where we do not have an overlap. Okay, all right, a trigonometric one. So here we have a system of differential equations. So let's write it. X prime is equal to 1, 2, 3, 4 x, and the f is sine t cosine 2t. All right, so now let's write the eigenvalues. So eigenvalues are very complicated like this, roots. Okay, look at the roots, and the eigenvectors are given here, and the general solution is also given here. Okay, so just see that the way we have written the general solution. So it's e to the that complicated eigenvalue. Okay, now it's the particular solution part that worries me. Okay, so let's look at the f. This is capital F, and identify the different type of functions you have there. So we have a sine t and we have a cosine 2t. All right, now write a vector for each of these function parts. So for sine t times a b vector plus, now remember, what did we do when we have trigonometric functions in chapter 4? If we have sine, we have to write its cosine version also, right? We have to have both sine and cosine. So cosine t cd, because you have sine here. Okay, so it's the same rules. All right, it's just we have vectors now, plus cosine 2t. Okay, cosine 2t, a b c d e f plus now we have to account sine 2t also. Okay, so GH. Okay, so this A, B, C, D, E, F, G, H are all constant to be determined, like capital ABC in chapter 4. Okay, so this is our guess for particular solution, initial guess. Now compare. Now if you look at the complementary solution, there's no sine cosine terms at all there, right? So do we have an overlap? Definitely not. Okay, so definitely no overlap. So this is our correct guess for the particular solution. Okay, all right, oops. Okay, so that is how we come up with a correct guess. Okay, in the next video let's learn how to deal with when we have overlaps. Thank you.